a few people that are apparently still stuck in finishing their nails and so on. So we will have a few more people coming during the talk, probably in the next few minutes. But we should make a start. So this afternoon we have a demo and followed by 2 workshops. A little bit in the same spirit as yesterday, and apparently talking to the speaker much more organized than yesterday. I can blame myself for that. So we have 2 speakers. The first one from CNR in Bari is Angela Altomare, and she will make a demonstration about Expo, and this will be followed by Van Czerny on the demonstration of Fox, and followed by the tutorials later on. So the first speaker.
Thank you. The aim of my introduction before the workshop is to give us just an idea about the procedure corresponding to each step of the solution process by Expo 2011. For some general consideration, in order to understand why Expo 2011. In the last 20 years, the role of powder diffraction has been considerably increased because of several reasons. First of all, many computer programs have been developed, synchrotron radiation has been proved very useful, attention has been devoted to improve the experimental resolution of conventional home diffractometers, several and new sophisticated computing strategies have been proposed. In spite of such advances, crystal structure solution by powder diffraction data is still a challenge. And this is because the overlapping, the background, and the preferred orientation make no stride forward the interpretation of the experimental powder pattern. So that each step of the solution process by powder is compromised by the low accuracy of the integrated intensity extracted from the powder and associated to each reflection in the powder. In fact, peak overlap, wrong background estimates, and preferred orientation occurrence introduce errors on the structure factor moduli, and this makes the difference with respect to the single crystal case. We have seen this morning that the structure factor moduli play an important role in the ab initio solution process. The phase is lost, the phase of structure factors is lost. We have seen this morning, Giacovazzo has told about the phase problem, and therefore the ab initio solution process is not trivial. The research activity of my group has been aimed at realizing a unique program which is able to carry out automatically the full pathway of the solution process by powder, and at improving and optimizing more and more all the steps of the process. All this is in Expo 2011. Expo 2011 is the update version of Expo package. Expo is freely distributed to public research institutions. Expo 2011 is able to solve by using ab initio and non-ab initio methods, as we will see. I would like to show the Expo team: Altomare, Pocci, Giacovazzo, Moliterni, and Rizzi, and the distribution of Expo package in the research laboratories in all over the world. The Expo package has been recently integrated in the powder software by Regard. Okay, the crystal structure solution by powder diffraction data can be carried out by following 2 alternative strategies. The ab initio reciprocal space method like direct methods. They are very sensitive to the accuracy of the integrated intensity extracted from the powder, and the non-ab initio direct space methods, which avoid the extraction of the integrated intensities, but they need additional information, the expected molecular geometry. And in this case, the number of structure freedom degrees plays a central role. Hybrid methods combining both can be applied also. Expo was born as a direct methods-based program. Expo 2011 is able to solve by using direct space methods also. And now let's see the main performance is able to determine the cell parameters. It is able to recognize the correct space view, to extract the integrated intensity, and to derive the normalized structure factor, the experimental structure factor, to phase the structure factor by applying direct methods, to calculate the electron density map, to chemically interpret the model in the map and to optimize it. Alternatively, it is able to provide the structure model by direct space methods, and finally, it is able to refine the structure model by the refinement method. All this is supported by a very efficient graphic interface, giving the user the possibility to follow step by step the evolution of the program, and high level of automatism, but of course, spatial strategies can be applied also for ad hoc problems, and organic structure, inorganic, metal-organic can be solved by Expo 2011. But now let's see the difference between the ab initio solution process and the non-ab initio solution case. You see that in the ab initio solution process, all the steps are executed, while in the non-ab initio solution case, the extraction step and the phasing step are avoided, are skipped, but additional information is required. Okay, about my introduction to Expo 2011, I will give very brief and qualitative descriptions of the procedure corresponding to each step of the solution process by Expo 2011, and I will avoid the references, and I will give some examples of application. In particular, an example of application of a default run by Expo 2011 for the solution of the paracetamol fracture, and 3 more examples of application of spatial strategies in Expo 2011 corresponding to not default runs. From now on, we will follow the solution process, the ab initio solution process of paracetamol fracture. In order to run the program, the Expo icon must be clicked, and the first step is the creation of a new working project. Paracetamol structure data have been kindly provided by Bill David Gu. The following graphical window appears, by which the user has to provide the experimental pattern information, in particular the name of the ASCII file containing the experimental counts. In this case it is paracetamol, the first point PAL. The file format, in this case it contains 2 columns. In the first column the 2 theta values, and in the second column the corresponding experimental intensities, but several other formats are available. The type of radiation, if synchrotron, neutron or X-ray, they are X-ray data, and the wavelength, no more. This is the minimal information necessary to the program for starting in an ab initio solution way. Of course, we know we need to know the cell parameter, the space view, the structure model by direct method, and as soon as we save this just given information, the program immediately creates an input ASCII file. Its name is paracetamol, the first point X, containing the most important command for running the program in a default way. And this file is very useful in a successive run of the same structure instead of starting again with the creation of the working project. In this file, the percent character is followed by a command line. So window is for activating the graphic interface, structure is followed by the name of the binary file containing the most important computational result, job is followed by a command line, init is for initializing the binary file, data is a command followed by direct is for providing the experimental pattern information, just as done. Find space is a data directive for searching the space view, and reor is a command for indexing, and continue is to go on up to the end, up to the structure model. At this point, the experimental pattern is shown by the graphical interface, and several graphical tools are available for the pattern visualization. in order to go on with the solution process, the next button must be clicked, and the next button will guide us during the full solution process. Okay, at this point, the next step is indexation. But before indexation, a peak search in the experimental pattern is automatically carried out. The automatic peak search procedure in Expo 2011 is based on a filter method for searching the peaks and a derivative method for the best peak location. After the automatic peak search, the list of the d-interplanets distance values is available, and this list is used for indexing. Indexation is carried out by Entreor 09, the update version of Entreor. We have optimized it and introduced it in Expo 2011. Among its main features, I remember that it is able to successfully index structures, also in case of large 2θ0 errors. And we have introduced in Entreor 09 a new figure of merit from new, which includes the classical M20 figure of merit, but it is more powerful than it. It is able to select the best cell among some possible ones. In these slides, we see the automatic indexation procedure by Expo 2011. So, after the peak search, the list of the d-values is available, indexation is executed, a list of possible cells is obtained, the lists are then transformed into conventional cells, and then the cells are refined. At this point, a 2θ0 shift is systematically applied to the experimental d-values in order to obtain additional possible cells and in order to take into account possible 2θ0 error. This is cyclically repeated, and at the end, the list of the possible cells is given. The cells are ranked according to the form new figure of merit, and the cell corresponding to the largest form new value should be the best one. The triclinic search has been improved in Expo 2011, and it is important to put in evidence that the new figure of merit is very effective. It contains 5 terms. The first term depends on the classical M20 figure of merit. The other 4 terms take into account additional information coming from the experimental pattern, the overlapping of reflection, the extinction, and the number of an index line. Okay, now let's come back to our paracetamol text structure. And this is the automatic research of the peak search procedure by Expo 2011. So the small vertical bars above the peaks in the pattern correspond to the position of peaks automatically detected by the program. And of course, error, in this case they seem to be reliable, but errors or approximation by the automatic peak search procedure can be corrected by using the graphic interface by adding or removing peaks. In this case, it is not necessary to add or remove peaks. The automatic peak search has worked well. So the list of the d-values is available, and at this point, indexation is carried out. Only one cell is provided. We see it's a monoclinic cell. The classical M20 figure of merit associated to it is quite large, 55, and the new figure of merit from new has its maximum, its optimum value, which is equal to 1, but because in this case only one cell has been given. As soon as we select the found cell, in the graphical window containing the experimental pattern, in the bottom part here, we see the position of all the reflection generated according to the selected cell, so that the user can check the reliability of the provided cell by comparing the position of reflection with the position of peaks in the experimental pattern. So, the provided cells seem to be reliable. And in this graphical window, we see that the selected cell has been stored, and at this point, the unit cell content value must be provided. Up to now, we have given only the experimental pattern information. Now, in order to go on with the ab initio solution process, it is necessary to provide the unit-cell content values corresponding to each chemical species. As soon as these values are given, the volume per atom is immediately shown so that the user can confirm, can validate the given values or can modify them. Okay, we can say that the indexation procedure by Expo 2011 for paracetamol structure has been successfully executed in 6 seconds in terms of CPU time. The indexation procedure has been tested on about 100 test structures covering all the crystal system and with different levels of data quality. All of them, but 2, have been successfully indexed. The 2 unindexed structures correspond to cases in which the percentage of impurities is very large. I would like to say that Expo automatism is, of course, a great help, but a careful inspection at each step of the solution process is necessary, is important. And this can be easily done by using the very useful graphical interface by Expo 2011. So my suggestion is, don't use the program as a black box, but use your mind and the graphical interface to validate or reject the automatically obtained results. Okay, after indexation, the indexation procedure by Expo 2011 is able to successfully index more proteins also, and I give you some examples in this case that have been provided by Irene Margiolaki. Now, indexation has been executed. The next step is the space group determination. The space group determination procedure is based on the calculation of the probability value associated to each extinction group compatible with the crystal system found in the previous indexation step. The probability calculation is based on a statistical analysis of the integrated intensity extracted from the pattern by using the largest Laue symmetry with no extinction condition. So, the probability associated to each possible extinction group is obtained as the product of the probabilities corresponding to each symmetry element contained in the extinction group. The graphical interface provides the list of the possible extinction groups ranked according to their calculated probability values, and the extinction group corresponding to the largest probability value should be the best one. The space group 1 or more than 1 corresponding to the best extinction group is considered. But let's go into some details about this procedure. So the first step is the extraction of the integrated intensities by using the largest Laue symmetry with no extinction condition. For example, in the monoclinic crystal system, as for our paracetamol structure, the used space group is P2 over n, which has no extinction condition. Then, all the possible extinction groups compatible with the crystal system are considered. In this case, in the monoclinic case, they are 14. And after that, the integrated intensities are normalized according to the Wilson plot. Then, the probability associated to each extinction group is calculated. And for example, the probability associated to the extinction symbol BB space B is given by this expression, where you see that all the symmetry elements contained in the BB space B extinction group are taken into account. BB space B, of course, is valid in the orthorhombic case. For example, the probability corresponding to the symmetry element 1 along 0, 1, 0 is given by this expression, where this is the average Z value. Z is the normalized integrated intensity suitable weighting. And the average, is calculated on the class of reflection which must be extincted because of the presence of the corresponding symmetry element. So, in this case, the summation is over the reflection of type 0, K0, K odd. The average Z value is given by this expression, where Wj is a suitable weight associated to the integrated intensity estimate, which takes into account the overlapping of reflection and therefore the quality of the intensity estimate. The conclusion is that the smaller the average Z value, the larger the probability associated to the symmetry element. Moreover, the space group determination procedure by Expo 2011 provides some very useful graphical tools which gives the user the possibility to accept, to validate, to confirm the automatically obtained extinction rule or to reject it. Because it may be that the largest probability extinction group is not discriminated from the other one, or the statistical is not significant. So the user can discard the largest probability extinction group, also if estimated with a large probability value. The list of the space group 1 or more than 1 is also provided, and if more than one space group is possible, the solution process should be carried out according to each possible space group, or additional information coming from, for example, from already solved structure could be taken into account. Let's see the result for our paracetamol structure. Here we see the list of the 14 possible extinction groups ranked according to their calculated probability value. At this step, a careful inspection is important. So we do not accept the result automatically, but we have to mind. In this other, if we select the largest probability extinction group, in this other graphical window, the list of reflection which must be extincted because of the presence of the extinction group is given. So, for example, reflection of type 0K0K odd must be extincted because of the presence of the 2-1 symmetry element, and reflection of type H0L, H plus L odd must be extincted because of the presence of the unsymmetry plane. In addition, the probability value to be extincted is associated to each reflection, and the information if it is a single or in overlapping. So, in this other graphical window containing the experimental pattern, in the bottom part we have the position of all the reflection generated according to the found cell, but immediately above them, here, the small vertical bars, we have the position of reflection which should be extincted because of the presence of the selected extinction group. The position of reflection just as listed in the previous graphical view, so that the user can check the reliability of the largest probability extinction group by comparing the position of reflection with the position of peaks in the experimental pattern. In our case, the largest probability value has been associated to the extinction group P to 1 over n. It is not a large value because it is equal to about 0.7 and the maximum value is equal to 1. But what is important to say is that the largest probability extinction group is discriminated from the other extinction groups. The provided solution ceases to be reliable, and so we can accept the automatic result. In this case, only one space group is compatible with the extinction group, with the largest probability extinction group, and so we can say that the space group determination procedure for paracetamol structure has been successfully completed, and the time spent up to now has been 11 seconds. The space group determination procedure has been tested on several structures covering a large variety of cases. For many of them, the correct space group has been automatically recognized. For some other structure, the graphical interface had to reach the correct choice. Okay, we have determined cell parameters, the space group. Now the next step is the structure solution by direct method. After indexation and space group determination, the integrated intensities are extracted from the experimental pattern by using the found space group according to the Lebel method, and then the normalized integrated intensities are derived. The experimental structure factor moduli are derived. After that, direct methods are applied for phasing the reflection, for phasing the structure factors. Carmelo Giacovazzo has spoken about the direct method this morning. Several phasing trials are generated. 20 of them are stored and ranked according to some figures of merit. The phasing set corresponding to the largest combined C-form figure merit is automatically selected for the next electron density map calculation, and then the model in the map is searched and optimized by Fourier recycling procedure. If the model obtained at this point is not reliable, then a different phasing set can be attempted, can be proved. The model is preliminarily refined by the squares, and after it is chemically interpreted and graphically provided. The problem is that the crystal structure solution by direct methods is usually approximate. And this is because we have already said that the structure factor moduli are affected by errors because of overlapping background, preferred orientation, and so on. So some atoms are missed to the complete solution, false positions are present, some positions are far away from the true ones. It is necessary to improve such a model before the final Rietveld refinement, because we know that the Rietveld method has a modest convergent rate, and therefore it needs a good starting model in order to obtain a good outcome. This is the structure model we obtained for paracetamol structure just after the phasing process by direct method. We see it is not interpretable. Also, if in a posteriori analysis we can check that some atoms are quite correctly located, but of course false positions are present and some other positions are far away from the true one. So it is necessary to improve this model. It is not possible to refine this model by Rietveld method. And so we have developed an automatic least square Fourier recycling procedure for optimizing direct method model. This procedure is based on least square, which uses as observation the integrated intensity extracted from the pattern, but suitably weighted according to a very powerful weighting scheme which is able to compensate the low accuracy of the integrated intensity estimate, in particular of reflection in overlapping. The procedure consists of 8 blocks, each block constituted by weighted square and successive 2F4 minus FC map in order to obtain missed position. At the end of the 8 blocks, the model corresponding to the best RF value is selected. It is further on analyzed. Poorly connected atom peaks corresponding to low intensities and large refined isotopical thermal factors are rejected. The automatic least square Fourier recycling procedure is the default choice for optimizing direct methods model in case of inorganic compounds. Because for the organic compounds, we have developed a different strategy which is able to take into account the limited experimental data resolution. Because we know that for the organic compounds, the experimental resolution is usually far away from the atomic one. Ken has spoken about this morning. And this is a very serious problem. In fact, we know that the limited experimental data resolution distorts the Fourier synthesis even at atomic resolution. It happens that the map is an imperfect representation of the true electron density. The worse the experimental resolution, the less accurate the Fourier representation. And the problems are very critical when the experimental resolution is much larger than 1 angstrom. In fact, it happens that some regions of the electron density map become negative, peaks are broadened and surrounded by ripples. And I show you an example of an electron density map calculated at the experimental resolution of 1.54. So we see the main peak and the ripples. And if we remove the main peak, we see that the ripple contribution is not negligible. So it happens that main peaks and ripples combine in such a way that the peaks are moved from their correct position and peak intensities are distorted. And so we have developed a procedure which is able to correct the electron density map by the resolution bias errors. And we have verified that the corrected map is much more reliable than the uncorrected one. I have to say that this is a very important result we have obtained, especially for powders, because in case of powders, the errors due to the limited experimental resolution combine with the errors on the experimental structure factor moduli and on phases. We have developed 3 kinds of approach working in this way. The first approach works in direct phase by modifying directly the electron density map, by correcting directly the electron density map. The second approach works in the reciprocal space and corrects directly the atomic scattering factor. And the third procedure combines both. The resolution bias correction procedure working in direct phase is the default choice for optimizing the direct method model in case of organic and metal-organic compound. And so we remember, about this procedure, the principle is the following one. Each peak in the map can be described by 2 components, the main peak and the ripples. And each component can be mathematically modeled in its domain. The main peak in its own domain and the ripples in the rest of the unit cell. So that the procedure consists of 2 main steps. In the first step, the ripples are subtracted from the electron density map. And in the second step, each main peak is well described by a best-fitting Gaussian function. I remember the structure model obtained for our paracetamol structure after the phasing process by direct method. The experimental resolution in this case is 1.43, and this is the model obtained after the automatic optimization by the resolution bias correction procedure. The structure is that the model has been completed. All this from the beginning is in 30 seconds. And now the final step is the Rietveld refinement. We have introduced in Expo 2011 a preliminary automatic Rietveld refinement. It is based on the classical Rietveld parameter about the minimization algorithm. It uses a Gauss-Newton algorithm combined with a line search procedure. It is possible to apply restraints on distances, angles, and planes. And this is the graphical interface corresponding to the Rietveld environment in Expo 2011. We see that it is possible to automatically refine the model, both the model and the profile. And if we attempt the preliminary automatic refinement for our paracetamol structure, the RP profile reliability value becomes about 5, starting from about 10. So at this point we can say that the ab initio solution process by Expo 2011 for paracetamol structure has been successfully completed in 48 seconds. I will show this, of course. I would like to remember that direct methods are able to provide several phasing trials. 20 phasing sets are stored and ranked according to the seafoam figure method. The phasing set corresponding to the largest seafoam value is automatically selected for the electron density map calculation. So if the model obtained at this step, if the model obtained at the end of the default run by Expo is not reliable, do not abandon the program, do not stop it. A different phasing set can be attempted, and I show you how this can be easily done by using the graphical interface. This is, for example, the structure model obtained at the end of the default run by Expo concerning an organic compound. It is not important to know which one. In this graphical window, we see the list of the 20 stored phasing sets ranked according to the seafoam figure merit, but in this case the seafoam value is not significant. It is equal to the maximum value, which is equal to 1 for all the phasing sets. So the user can easily select one of them or all of them. In this second case, if all the phasing sets are selected, the solution process is carried out up to the end, up to the structure model for each phasing set. At the end, the model corresponding to the smallest RF value is automatically selected and graphically provided, but of course the structure model corresponding to each phasing set can be considered. Okay, and now all this is for the ab initio solution process. When direct methods fail because the experimental solution is very bad, for example, larger than 1.5 angstrom, and or the structure is complex, the number of atoms in the asymmetric unit is larger than 40, and or the data quality is bad, and the knowledge of the expected molecular geometry is available, then the solution process can be attempted by using the direct phase method in Expo 2011. Two possible strategies can be applied, which are based on the direct phase method. The fourth is an automatic standard simulating annealing procedure, and the second procedure is an hybrid procedure which combines the information contained in the electrodensity map provided by direct method with a direct space method based on simulating annealing as minimization algorithm for providing the most reliable configuration. And let's see this second procedure. In particular, we will see its application to the solution of the organic haptoprene compound. This data will be provided by Bill David also in this case. And this is the model we obtained after the default run by Expo 2011. It's completely unreliable, but this model can be exploited. It can be used in the following way. We import a trial model according to the expected molecular geometry, and the program is able to automatically describe it in terms of bond distances, bond angles, and torsions. And then each peak in the map is associated to each atom in the model. So the origin is fixed, the origin is not varied. The number of freedom degrees is reduced with respect to the standard simulating annealing technique, and therefore the probability to reach the correct solution is higher and faster. Of course, it is necessary that at least one position must be correctly located in your map. After each association, the torsion automatically detected are varied. In this case, 4 torsions are varied. And the correct solution for haptoprene compounds has been obtained in about 2 minutes. In these slides, we see an example of application of the standard simulating annealing procedure by Expo 2011 for the solution of the ibuprofen compounds having an experimental resolution of 1.5. The procedure is based on the classical simulating annealing parameters, and this is the graphical interface by which the user can modify the default parameters in terms of consumption, number of movements, and so on. The correct solution is found in this case in about 3 minutes. And in this slide, some other example of successful application of the standard simulating annealing procedure. We can say that up to 15 freedom degrees, the correct solution is automatically reached. In case of more than 15 freedom degrees, it could be necessary to modify the default parameter. And now, very fastly, before going to the conclusion, I would like to speak about another procedure which can be used in Expo 2011, which is very useful for solving polyhedrally coordinated structures. Because we know that in case of heavy atom structure, the model completion is very difficult. The heavy atoms are quite easily located by direct methods, but the light atoms are difficult to reposition. The chemical level is not correct, false positions are present. So, when the structure is polyhedrally coordinated, tetrahedrally or octahedrally, the Polpo procedure can be applied for obtaining the correct model. The Polpo procedure is an hybrid method which needs two kinds of information. The correct location of the cations, just as provided by direct methods, all of them of some or some of them, two possible Polpo procedure can be applied, and the polyhedral coordination information about the located cations, tetrahedral or octahedral. Starting from this minimal information, the program is able to generate several models according to the polyhedral coordinated information, the provided polyhedral coordination information. The models are randomly generated according to Monte Carlo technique by geometrical construction, and at the end, the model corresponding to the best figure of merit is provided. Okay, this is the application of a chromium compound. We start from the position of only the 4 chromium atoms, and we provide the polyhedral coordination information concerning them, and the correct model is fastly reached in less than 1 minute. Okay, the officially distributed version of Expo is Expo 2009, which can be downloaded by our website. But the version you have received in initio is the very last version, Expo 2011, which is of course better than Expo 2009, but it is a version still in progress, so some errors may occur. Keep it confidential, and do not forget to sign the license agreement and to give me it. I have prepared for the workshop a README file. I suggest you to read it carefully and to follow the structure for running and installing the program. I have prepared a very detailed description, so you can run the program by alone. Okay, thank you for your attention.
Thank you for this very nice and detailed presentation. Questions? Yeah.
Henrik from Stockholm. Is there a particular reason why you have chosen using Lebesgue fit instead of Polyfit, which has been used for several programs? Using Lebesgue fit instead of
it's a strategy for obtaining the preliminary parameters which are then refined by the data.
But instead of Polyfit, which you have heard of today?
We prefer Lebesgue. We historically prefer Lebesgue.
Any other reason than historic?
No, of course the reason is not from a historical point of view.
Questions? Yeah.
I found a way to use more molecules, to use simulated annealing in Expo. I never tried the hybrid methods because I never found a way, since I work with co-crystals and
You could try, but remember that it is a preliminary.
Of course, yeah, but I'd like just to try.
It can be useful you to be sure, not completely sure, but to have an information that your model is reliable.
Of course.
Just an information.
Of course. But I'm asking, is there a way to charge more than one molecule, to load more than one molecule with hybrid methods in Expo? My question is more than one molecular model for one structure with hybrid methods?
No.
Oh, so
at the moment it is not possible. No.
Okay, that's why I never used the hybrid methods.
Okay, other questions? Yes?
Saul Peter, Stony University. You know, behind the scenes, you're creating a map and assigning atoms. Is there any way to view the map itself? Okay. Is it easy to be found inside Expo? I don't have much experience. You know, not just the atoms, it's just with the.
You mean the density map?
Yes.
Is it easy to visualize, I guess, and compute?
To see as a visualization, you mean in this version, no. Or you can, but the procedure is not efficient. In the next version, we are working about that.
Other questions? I had a few questions myself. First of all, does it work on different platforms? Is it work just for Windows or also for Unix? Or
Linux, yes, I have not. Sorry. It's for Windows and Linux, yes, not for Apple.
And the other question I had was, once you have done automatic indexing, and it's, let's say you've selected a particular group, can you use a non-conventional setting of this group if you want
No.
to? No, you can't.
No.
So it's, okay.
No.
Any other question?
Not in the automatic space group determination.
Okay, then we should thank our speaker again. And the second speaker is Radovan Czerny, and he will tell us about Fox.